we will have a short presentation of one of our sponsors, Sonel Instrument. Mr. Shyam Ravindran will lead us through. The stage is yours, sir.
Can I have the slider? The slider. Thank you. Thank you. So good afternoon once again. So today my presentation will be about power quality. There is a section 20 in NEC 23 which talks about power quality. My session will be briefly about power quality, the products and tools that is used for the measurement of power quality, the power factor and harmonic corrections which is also mentioned in the standard, some case studies because we've already done some case studies. Tamil Nadu, to be very frank, is a very matured state in terms of power quality and power quality improvement, we know that. And a quick introduction about Sonel Group. I have only 15 minutes for my presentation. I know that power quality is a 2-day topic. It's impossible to complete it, but I'll briefly touch what is the topics in my session. So first I will exactly point out what is a definition written both in NEC as well as in IEEE. The power quality is defined as an electrical boundary that allows the piece of an equipment to function in its intended manner. I took out this IEEE definition also to show it is almost a similar definition, but they have added also grounding of the sensitive equipment. So this is exactly the definition that is copied from NEC 23. Yesterday and today we are all discussing about NEC plus a brief idea about what is the CA guidelines that is going to come out in the safety regulation. But if you will go to the grid connectivity in CA website, you will find this interesting document of power quality analysis. This is for the prosumer area wherever an electrical vehicle charging station is being connected. So if something is connected to the grid as a prosumer, these are the list of mandatory methods that is already provided as a gazette tool in CA website even. In a nutshell, you will have to use a continuous monitoring of power quality because that is a very significant subject. You will be also using a Class A power quality analyzer standard 61004-30 Class A. This is the tool that must be used. Please note, it must be a continuous process, not on and off testing of power quality. It is clearly mentioned it must be a continuous monitoring of power quality. It is a significant topic. It is a significant topic to the consumer also. It is a significant topic also to the grid company because we know there is a lot of articles and publication that is there. If a power quality is not maintained properly, what is the impact that is happening to the grid? Let it be any grid company, whether it is TNAB or any other grid company, there is an impact of power quality not maintained in the prosumer end. So that is why it is a very significant topic. Now this is a tool what we wanted to present it to you. This is our Class A power quality analyzer, edition 3 certified equipment. A brief idea about this equipment is, of course it has all the necessary provisions to make power quality. When we talk about power quality and when we say that the standard is complied, you can be 100% sure whoever will be the manufacturer, doesn't matter it is from Sonel or from any other manufacturer, when the necessary standard and the certificates are produced to you, it is as similar to your energy meter what you purchase from your home. Today it can be X manufacturer, tomorrow you can change it to Y manufacturer, but what you are consuming is going to be your consumption pattern. Similarly, this edition 3 power quality clearly classifies. The only differentiating factor a manufacturer can give it to you is how the data is transferred, whether you want an online data transmission, whether you wanted a continuous monitoring. So these are the extra provisions. In our equipment, from the application point of view, yes, it is a continuous monitoring. Because it is a continuous monitoring, the design itself is made in such a way that you don't need an additional socket. The testing and the supply mains remains as a common area. And in terms of the specification, we offer transient protection up to 10 megahertz with a 200 millisecond as a measuring sampling rate, which is one of the highest in the market currently. But this is not mentioned in the Class A standard. Please note that this is not mentioned there. So this is something that we offer extra to the customers. In terms of power factor, this is from NEC. NEC talks about power factor improvement, measurement, and also some philosophy and some technical ideas on improvement of power factor. So we know what is power factor. but the point 3.1.1, which is shown in the presentation, I wanted to read because it was very difficult to understand in the first place, but then when we read it again and again, it was much easier for us to understand. So basically, when the tariff of an electricity board and the licenses are based on kVA or kW demand plus kWh billing with a suitable penalty for low power factor and suitable rebate for high power factor. It is a continuous sentence for everybody to follow through. I put it into the second line. It's an example of Tamil Nadu, for example. We being not in the kVAH billing like other states, you will have to maintain your power factor. If you don't maintain your power factor, there could be a possible penalty or a rebate that varies from state to state again. If you are in a kVAH state, it is understood that if you maintain your power factor, you are going to have an electricity saving. It's clear. But when you come into the tariff amendment of TNEB, this is an extract from the tariff of TNEB. If you do not maintain your harmonics, you have a 15% penalty. Please note this can vary from state to state. In Maharashtra, the scenario is different. In the state where the kVAH billing is applied, in the other states are completely different. Also, it can completely vary from state to state. In TNEB, there is a 15% penalty. So this is an extract from the NEC document on power factor correction. We know a non-linear load is going to generate, the word generate, it is infused to me for many years. It's not generate. The word that is used in NEC is I like this word. They used a word called cost. The non-linear load cost harmonic current, because all these days I'm repeating generate. We know it is not true, but this is what is written in the standard. So the harmonic current which is caused by a non-linear load, when there is a capacitor, we know because of the capacitive reactance, the capacitors are prone to have having a problem when there is a high harmonic current. So the design already proposed is with using a series when you use an inductor, there are three types, what type of tuning of an inductor you will be able to use, whether it is 5.1%, 7%, 14%. And power quality is such a phenomenon, there is no thumb rule. If you will ask me an example, Sham, what would you recommend, 5% or 7%? Nothing is a thumb rule here. Only after we do an audit, we will be able to prescribe any kind of a solution. Even for a simple power factor improvement that I cannot make a tabular column, it is mentioned in NEC also, how the power factor can be improved in tabular column. But when you go into site, everything goes to the north. This is what I learned from power quality as a topic in general. And effects of harmonics, we know this, any harmonic problem reduces the life of the asset inside the customer premises. In my opinion, this is a very important point. We have seen customers fighting against the utility or not very comfortable when they talked about the harmonic as a problem. But having said that, if you go to a hospital, we have a lot of experiences. Once when the customer was not very sure, no, there is nothing, there is no problem, everything is okay. But then they say that my sensitive electronic equipments do not even start in my facility. So as a customer, there is a lot of benefit to the customers as well. Plus, the grid is also having a lot of benefit on maintaining the power quality. But today in India, when we talk about power quality, even if we discuss a lot of parameters as voltage, sag, swell and other parameters, when it comes to the economics of power quality, we are all very curious about what is the measurement of power factor and how is our harmonic current being limited. This is also taken from NEC 23 only. Few suggestions, whatever is highlighted in the red, it is exactly a copy paste from NEC. They have told or recommended, it's not a product standard as what was mentioned before, but it's just a suggestion. Using of an active harmonic filter is suggested in NEC 23 to improve power quality. So I wanted to present few case studies. We have done a lot of case studies across Tamil Nadu. About 120 installations are there for us in Tamil Nadu. We did about 600, 700 audits, but after COVID, this is not a very predominant exercise that we do currently. But we know that TNEB is again picking up the topic of power quality again. So this was done before COVID scenario. So this is an injection molding plant. Please note that the tabular column, what we try to show you, I mean, as a consultant or a company who wanted to give a solution, our tabular column will be, or our solution will be on the LT side. For what we mean is on the 440 side, 440 volt side. But then whether we are okay, whatever we did is correct or not, is actually tested and approved by TNEB MRT department. So if I compare, for example, what is my harmonic percentage in 34.98 is actually what I will be doing it on the LT side. Then the solution what we did here was an 150 ampere harmonic filter installation. This 5.58% is actually verified and given from the TNEB. So it's not actually on the LT side. If you will check on the LT side, it will be a slight variation, but in a marginal factor, it is very well falling within the CA guidelines of 8%. CA guideline says the current harmonic shall be maintained below 8%. This is the norm. This is an injection molding company. This was a very interesting example because there is not many loads inside the company, only one drive, a large drive, and that's it, 10 computers. This is a company based in Sri Perumbudur. So once when the molding starts, the harmonic current increases so rapidly, and once when the drive stops, the harmonic current falls absolutely low, and there is no other load pattern inside the company also. So it was like on and off kind of a load, which we were able to do with an active harmonic filter installation. Then an example of panel fabrication. To be on the on the easier note, again, I don't want to present it as a thumb rule or this is how we will be able to do a power quality analysis. What I personally understood in this total exercise was, when you have a single phase load as a predominant load inside the customer premises, our approach was towards the triplet harmonics. When we had a processing load, for example, a textile plant or other three-phase loads, we were focusing on the 5th and 7th order harmonics. I already got my bell, so I am the guy who is standing in the middle of your lunch. So I'll just skip it through. I will be having my presentation with me after the lunch. If you're anybody having a question, I can comment on it. We have done some in welding loads, some in foundry. Foundry is a very classical example. It is very difficult to bring a power quality solution in a foundry plant. Garments printing, cold storage, automobile spares, shopping mall, IT, ITS. But for an electrical engineer, shopping mall and IT, ITS is almost one and the same because it is mostly a chiller plant. I'm done, just one second. Granite industry. We also do a lot of PQ analysis on the EV charging stations area. If anybody is interested to have a discussion, I will be available for the discussions. This is the list of customers for our company in India and globally. We operate in totality about in the transmission side, in the grid side, and also on the industrial side. So today we will be, we have just focused on the safety part of it. And one more point with what Mr. Gopakumar told about the pad testers, I have the product that is kept over there. In the interest of time, I will skip that point. So I will not take much of your time, and that's my slide. If this is my contact detail, if you have any questions, you can contact me. Thank you so much.